Hi friends, in this video we are going to see what are the generation methods of pulse width modulated signal. In general, you know what is a PWM signal and how it will be drawn from the message signal with a pulse signal. Okay, but here we are having a different methods in order to generate a PWM signal. So in this video I am mainly concentrate on most usable methods, that is using a comparator. First method is using a comparator and the second method is using a 555 timer IC. So let us see how the PWM signal is generated from the comparator circuit. So this is the circuit of a comparator. So at this output a PWM signal is generated. So here I am considering an op-amp based comparator circuit. So we know that whenever the op-amp comparator is used, it will be operate in the open loop mode. So to this op-amp, a message signal is directly applied to the non-inverting terminal of op-amp and a sawtooth signal is applied to the inverting terminal of op-amp. So before applying this sawtooth signal should be generated from a sawtooth generator and thereafter it is applied to the inverting terminal of op-amp. Now based on the comparison of these two signals, the PWM signal output will be generated. How it will generate a PWM signal is if the amplitude of message signal is greater than the sawtooth signal amplitude, then the output of a comparator value will be positive. Otherwise, if the message signal amplitude is less than the sawtooth signal amplitude, then the output of a comparator will be negative. Let us know how to draw the waveform of PWM signal. So here the comparator inputs are a sawtooth signal that is generated from sawtooth generator which is indicated with X of t, and the voice signal or a message signal it is indicated with M of t. So the comparator output, we know that it depends on both M of t and X of t. So the comparator output will be positive when M of t is greater than X of t, then the output of a comparator will be positive. Okay, if M of t value is less than X of t, then the output of a comparator value will be negative. So based on this condition, we have to draw the waveform of a PWM signal. So let us see. Before drawing the PWM signal, let us identify what are the touched points of message signal with sawtooth signal. So from this waveform, if you observe, so this is the coincide point of two waveforms. So first identify those points. Okay, so thereafter draw the PWM waveform. So here if you observe, here the message signal value is high compared to the sawtooth signal. So that's why the output of a comparator will be positive up to this point. At this instant of time, here the message signal is gradually decreasing whereas the sawtooth signal is gradually increasing. So at this point, since the sawtooth signal amplitude is high compared to the message signal, the output will be negative. So similarly, at this point again the message signal amplitude is increasing whereas the sawtooth signal amplitude is decreasing. So again the output value will be positive. So this is the procedure of drawing the PWM waveform with the known message signal and the sawtooth signal graphically. So here the obtained PWM signal, we are calling it as a two-level PWM signal. Why it is called a two-level PWM signal? Because it is having both positive peak and a negative peak. In order to convert the two-level PWM signal to a single-level PWM signal, this two-level PWM signal should be passed through one clipper circuit. Now what the clipper will do, it will clip any half peak of the signal. Okay, so either positive peak can be eliminated or a negative peak can be eliminated. So after passing a two-level PWM signal to the clipper circuit, it will simply obtain our one-level PWM signal. So that PWM signal either a positive level PWM or a negative level PWM. So this is the first procedure of generating a PWM signal using a comparator circuit. Now we are going to see how to generate a PWM signal using a 555 timer IC. So let us see the second method, how to generate a PWM signal using 555 timer circuit. So this is the circuit of 555 timer. Okay, so these are the output connections, and here these 1, 3, 5, 2, 4, 8, 7, 6 are the pin numbers. So here if you clearly observe, at the fifth pin of 555 timer IC, we are applying a message signal or a modulating signal, and at the second pin of 555 timer IC, we are calling it as a trigger input. So this trigger input is nothing but a train of pulse signals. If you observe what is the internal circuit of a 555 timer, then this is the internal circuit of a 555 timer. So here if you clearly observe, this circuit is consisting of only the comparators and a flip-flop, thereafter one output circuit. Okay, so based on this comparator operation, the PWM signal will be generated. So in the 555 timer circuit, at the fifth pin we are applying a message signal, but internally the 555 timer circuit is having a fifth pin, a control voltage, that is 2/3 VCC. So in addition to the control voltage, a message signal is applied to this upper comparator. Now we know what is the action of a comparator. So for the comparator, if the differential voltage, nothing but the two inputs of difference voltage is higher, then the V0 will be switches from positive to the negative or negative to the positive. In general, we are saying that if the differential voltage value is positive, or if VD is greater than 0, then the output voltage V0 is a positive value and its value is plus VCC. Okay, and if the differential voltage VD is negative, that is VD is less than 0, then the V0 value will be a negative voltage, that is minus VEE. So depending on this differential input voltage, the output voltage value will be switches either from positive to negative or from negative to positive. So for this 555 timer circuit, already at the fifth pin, the internal voltage of 2/3 VCC will be present. But in addition to the 2/3 VCC, some external signal. That external signal we are calling it as a message signal or modulating signal is applied, which in turn changes the control voltage level or the threshold voltage level. So in this way it will generate the PWM signal. So PWM is nothing but the width of the carrier pulse should be changed, and here the width of the pulse will depends on the time taken by the capacitor to charge to the threshold voltage value. So now what is the threshold voltage value? The threshold voltage value is nothing but the control voltage value, that is 2/3 VCC plus amplitude of the message signal. So how much time the capacitor is required to reach that threshold value, that is nothing but the width of a pulse that is calculated. So in this way we are generating a PWM signal using a 555 timer IC.